Welcome to lecture 29 of our C programming course. In the last class, we covered the core logical bitwise operators, and in this class, we will try to understand the operators from the same family, which is bitwise shift operators. There are two types of bitwise shift operators. One is left shift operator and the other one is right shift operator. So understanding these two operators is very important because these operators help a programmer to write highly optimized code. How these operators help, that we will understand by the end of this video. And understanding these operators are very common in the technical interview rounds. So we request you to focus more and try to watch this video multiple times until you get the clarity. Let's get started. So the first bitwise operator is left shift operator. So this is the operator that we are going to use, and we'll try to understand this concept by using this example. So the example states that 5 and there is a left shift operator and we have given 1. So what does this mean? What does this declaration means? That we will try to understand first. So what we are going to do is, so as we have discussed that the bitwise operator, whatever the operation that is there, those operators, the operation done by those operators is done on the bit level. So this concept we have already discussed in the previous video. So the binary value of this 5, on the binary value of this 5, we are going to shift 1 bit towards left side. So what is the binary value of 5? So this is the binary value of 5 represented in 8 bits. Okay. So now on applying this operator, what happens? That we need to understand first. On applying this operator, what happens is 1 bit will get shifted towards left, means this bit will be moved out, and all these bits will move a 1 step ahead towards left. So how this operation is done? And the immediate question that you are going to get is, so what about the last bit? So as we are moving towards left, what about the last bit? So this last bit will be covered by a 0. Okay, so how this operation is done, that we will try to understand first. So what happens is, so this position will be covered by a 0 and this one will get shifted to the left. This one is getting shifted to left. This one is shifted to left and so on. Okay, so now how many bits are there? 8 bits are there, and this is what the new bit that is getting inserted into this after doing the left shift operation. So this is how the left shift operation is done. So try to understand this process. We have to add a 0 at the start of it, and we are going to shift the bits towards left hand side. Okay. So this is how the logical shift, so the left shift operation is done, and this operation is also called as logical shift. Okay, so now what is that we are going to get from this? Whenever we do left shift operation, what is the advantage? What is the use of it? By shifting it, what we are going to get? So closely observe the values, the binary equivalent values. So the decimal equivalent for this binary value is 5, we know that. And what is the decimal equivalent of this value, of this binary value after left shift? It is 10. Now what we are going to do, what is that we are going to understand from this? What is that we are going to understand from this is, whenever we do one left shift operation, the given value, the actual value 5 in this case, will get multiplied by 2. Try to understand this. And this is very fast operation and highly optimized operation. Why? Because if you do multiplication 5 into 2, it is going to take lot number of steps. But if you do left shift, just shifting the bits, it is very fast, right? So that is the reason why by understanding the logic behind the shift operators, a programmer can write the code, highly optimized code. Means very fast operations. So just by doing this left shift operation, a number will get multiplied by 2. And if you want any such multiplications to be done, means by 2, if you want a number by 2, so this is the fastest operation possible, right? So that is why understanding these operators help a programmer to write highly optimized code. Now, what if I have done, what if I have given, instead of this one, I gave 2? What does this mean? So what I mean to say is, instead of this one, so if 5 left shift operation 2 is given, so what does that mean? Means 2 bits of the actual value will get shifted. Now if you shift 2 bits, what happens? So let's see that. So first 1 bit will get shifted, and the shifting is done one after the another. So first 1 bit will get shifted, and after that another bit, another operation, next bit will get shifted. So what happens is, so this one, the sequence of operation is, here a 0 will get added. Now this 0 will be shifted here, and this one will be shifted here, and similarly this 0, this one, and 0, 0, 0. Now what is the decimal equivalent of this? So the decimal equivalent of this is 20. Try to understand this. So 5 into 2, 10, and 10 into 2 is 20, as we have discussed. So in every shift, the actual value will get multiplied by 2. If you are trying to make 2 shifts, it is, so how can we understand this? So if this x is the, so how can we understand this is, the actual value 5 is multiplied by 2 power, how many bits we are shifting? 2 bits. Means 5 into 4, which is going to be 20. So that is the use of left shift operation. Now coming to our another operator, which is right shift operator. Now can you guess what is the advantage that we are going to get from this? So in the left shift operator, we have seen that it is multiplying the actual value by 2. And here in the right shift, what happens is, we are going to divide the actual value by 2. So let's see that. So what happens? Right shift. But how the operation is done? The operation done by the right shift. So the methodology used for the right shift operation is bit different from the left shift. That is why it is called as arithmetic shift. And the operations that were, the mechanisms that we are going to understand are common in every programming language. So what is this arithmetic shift? Right shift, arithmetic right shift. So what does that mean is, we are going to use the same bit, the rightmost bit is used as it is. So in this case, we have taken it as 0. Now the right shift is done towards right. Previously it is left, right? So now starting from this rightmost bit, the shift happens. So this one will come here. So this one will be 0. This one will come here. This one will come here. And this bit will come here. And this bit will come here. And this one here. And this one here. Now what is happening? So what is the outcome that we are going to get? And the decimal equivalent of this is 12. And the decimal equivalent of this binary value is 6. So try to understand this. And the operation is different. Whatever the value that we have in the rightmost part, that has to be used as it is. Why? That we will try to understand in our later coming videos. But in this video, you just try to remember this one single point. What does, in the right shift operation, what we have to do is, the rightmost bit, if there is a 1, that 1 has to be used as it is. But in our case, we are having a 0. So we are going to use that bit as it is, and now the shift happens. Try to understand this. That is the reason why. So this is what, this kind of operation is what we call it as arithmetic shift. Understand this. Okay. So now what is the result? The result is just divide the actual value by 2. And if you have done it again, means in the case of 1, if you have given 2, means 2 bits towards right. Shift 2 bits towards right. Now what happens? The other shift operation, the same, the rightmost bit has to be used as it is, and again shift it. Okay. So 0 and this 0 and this 0, this 0, this one is used here, this one is used here, and this one is used here. Now 8 bits. Okay. So now what is the decimal equivalent of this binary number? The decimal equivalent of this binary number is 3. Means 12 by 2, 6, 6 by 2 is 3. Okay. So this is how the left shift operators and the right shift operators work. Now the immediate doubt that we are going to get is, what about 13? What about 15? If you use left shift operation on 15, what happens? And what about minus 5? What about minus 8? Okay, if you do right shift operation on minus negative values, how they will get represented? So far in the previous classes, we never covered how the negative numbers are represented by a computer. So we are going to discuss those concepts in our later coming videos, and we will revisit the same concept of bitwise operations, bitwise shift operations there after covering the concept of negative number representation. Okay, so as of now, at this point of time, this is the very basic understanding of bitwise shift operators. Hope you understand the overall discussion. So that's it for this video. Thanks for watching.